Okay, so I want to go through one example of a circular motion type of problem. And this one says a Ferris wheel 24 meters in diameter rotates once every 12.5 seconds. What is the change in a 45 kilogram person's weight at the top and the bottom compared to rest? Okay, so kind of compared to at rest, when the person's at rest their weight is just equal to mg, right? So at rest, 45 kilograms times 9.8. At rest, their weight is 441 newtons. And as they go in this Ferris wheel, that apparent weight, or what they kind of feel is their normal, changes. Okay? So before we can kind of think about figuring out what the normal force is, or kind of what that apparent weight is, let's do a force diagram. So here's our Ferris wheel. And our Ferris wheel, the person doesn't go upside down, right? Like they are right side up the entire time as they move around. So at the bottom of the Ferris wheel, you've got your weight and you've got normal force. And at the top of your Ferris wheel, you actually have weight and normal force. So direction of forces actually doesn't change when you are thinking about a Ferris wheel, but what does change is the direction of the acceleration. Remember, centripetal acceleration is always going inwards, okay? So when I'm thinking about the bottom of my Ferris wheel, my centripetal acceleration is going inwards, so it's going up. But at the top of my Ferris wheel, my centripetal acceleration is going inwards, and in that case, it is going down, okay? So if I think about my top, my force equation, remember the direction of your acceleration is going to be considered positive. So at the top for my forces, I'm going to say weight minus normal is equal to MAC. And at the bottom, I am going to say that it is normal minus my weight is equal to MAC. Okay, so the directional change of acceleration causes you to change what you consider to be positive and negative in your math. Okay, and we are looking at the apparent weights. We're trying to find the normal force. So for the top, my normal force actually is going to be equal to my weight minus MAC, or N equals mg minus MAC. And then at the bottom, my normal force is going to equal my MAC plus my weight, or MAC plus my mg value. Okay, and I have my mass. I know what gravity is. I've got to figure out what AC is. What is the centripetal acceleration? And so remember that centripetal acceleration is equal to v squared over r. So I need to figure out my velocity is. And we are told the period of rotation. So we know that it goes around in a circle once every 12.5 seconds. So we also know basic definition of velocity is distance over time. And so we can think about this in terms of the circumference that it travels in a certain amount of time. So 2r, that's just my diameter, right? So I've got pi times 24 divided by 12.5. You should get the velocity is 6.03 meters per second. And so now you could actually plug in. If we know AC is equal to v squared over r, this is going to become my mass is 45 times 9.8 minus my mass times my v squared, so 6.03 squared over my radius. So remember radius, this is the diameter. So divided by 2 will be 12. And then same process here, this would just be 45 times, now we're just adding. Okay, and we should expect that at the top we almost feel like lighter because our inertia is like wanting us to keep moving upwards. and so we feel lighter. That normal force isn't as big. When we are going down into the loop, our inertia wants to like actually keep us going in that direction. So the floor has to combat the weight, but it also has to combat your inertia wanting to go downwards. So I would pause the video and calculate out what the normal force. I should do better. This is the normal force at the top. This is the normal force at the bottom. And I get that the normal at the top is 304.7, and that the normal force on the bottom is 577.3. So hopefully you got those similar numbers, and that again, that should make sense in terms of how normal force has to counter inertia.